Open source is usable for any purpose without restriction. And that means that there cannot be any restriction on fields of endeavour or how the code can be used by someone, not just who can use it. That's the same whether the code's being used to make money or not, and even if the purpose is one you might love or hate. Despite the fact that you're the creator of the code, once you make it open source, you cannot control that. It's an important part of being open source that there is no restriction on this. In Lesson 5, we saw how people communicate with each other. In old days, we used to use all sorts of ways to communicate, from carrier pigeons, telegrams and Morse code, to feature phones, and today our lovely smartphones and devices like tablets and gaming consoles. All of our devices allow us to stay in touch with our friends by chat or playing games with them. We also listen to music, do shopping and manage much of our lives on these through all sorts of different apps and skills. When we use our phones and devices for interactions, we use data from a mobile phone network, or we connect our phone to Wi-Fi to give us access to the internet and connection for communication. We think more about the internet in Lesson 10. The data and internet allow us to access the apps and services on the phone. All the data that we use is generated in a data center. Data centers are places that use a lot of energy to process and compute, which allows our phones and devices to use data. We use data when we watch streamed content like Netflix on TV. Netflix also builds a lot of the software it uses to provide its services to us on open source software. The same is true for many other streaming services that provide video and sound content to us. Can you imagine how much data we all use, or even how much you use? When data centers process this data, they use a huge amount of energy. All the servers and other IT equipment that is used to make this in a data center gets really hot. Maybe you've seen a phone or a computer or other electrical device get hot from all the processing going on inside it. Processing all of this data requires energy. And most of our energy comes from burning coal and oil, known as fossil fuels. This is a problem for many reasons. Fossil fuels are not renewable. Once they're used, they're gone forever. When you burn fossil fuels, they release gases that pollute the air we breathe. Burning fossil fuels also raises the temperature of the Earth's atmosphere, which is harmful to people, plants and animals. This is called climate change. Today, people have used up so much of the world's resources that we now have to take more care of it, now and in the future. We try to use renewable resources to generate power or energy in a way that is kinder to the planet. We try to use less of its finite fossil fuel resources and more of its infinite resources like sun, wind and waves instead of coal and oil. We do this to help reduce the negative impact on the planet. We try to preserve the planet by doing this and by being more careful to ensure that we're using our resources in a sustainable way. The people who run data centers, which create all of our digital data to let us play games and chat, are all trying to make our data use less energy and use kinder ways to generate the energy that data production needs. This all means that we use less of the planet's resources for our digital activities, and that is good for all of us and future generations of people and the creatures we share the planet with. The more data centers use open source software and open up data for sharing, the better it is for sustainability of the planet and aligns with the SDG 7, which is about affordable and clean energy. Even the United Nations uses open source software and open data to help governments and many other organisations reach and monitor their progress against the Sustainable Development Goals. We'll hear a lot more about this at COP26, the 2021 UN Climate Conference in Glasgow. In today's lesson, we're going to start to think about energy and how we might help the planet. We'll use our glove to understand more about how energy is generated. By the end of this lesson, you will be able to understand the importance of energy and the impact the energy in our data consumption has on the environment. understand that open source can be used for any purpose. Learn about scope and what the differences between local and global variables are. Learn what a conditional while loop is. Learn the importance of properly naming variables. Have you ever thought about how much electrical energy we use every day? We use energy in all aspects of our life, from lights to charging our phones and computers, to keeping the refrigerator running. Energy consumption, like open source, is everywhere, including in the data centres, generating data for us and our homes, our cars and transport systems, our schools, offices and shops. Everywhere and everything we do that is digital uses energy. Today, we're going to try and measure how much energy we can generate by shaking our glove for 5 seconds. The program will play a high note to say when you should start shaking and another to say when to stop. Shake as hard and fast as you can within those 5 seconds. But be careful that the battery pack doesn't fall out of the glove. Woohoo! That's fun! You're all becoming expert coders. But before we can tackle this week's program, there are some new concepts that we want to introduce. Scope and conditional loops. Have you noticed that some variables are assigned in function, while others are not? Nothing in programming happens by chance. There is a reason for this. It's called scope. Scope uses local and global variables. Sounds a bit complicated, but don't worry. We can work through an example together with my friends Elliot and Rachel. First up, global variables. These are variables which are defined in the main program and which can be accessed anywhere in the code. What this means is that I know its value wherever I use it in the code, either in the main program or in a function. In the example, I define the global variable friend. I can then print it. I then have a function called friend function. Within this function, I create another variable, friend2, and set it equal to Rachel. This is a local variable. A local variable is one which is defined within a function. It can only be read and changed within this function. This becomes important if, sadly, Rachel and I fall out. We're no longer friends, but I have a new friend called Michael. I won't be able to change the value of friend2 from Rachel to Michael from within the main function. If I want to change the value of friend2, I have to do it within the function. If I try to assign a new value to friend2 in the main program, it will instead create a new variable, also called friend2, with our new value of Michael. This means we now have 2 variables called friend2 with different values. Isn't that confusing? If we want to change the value of friend2, instead of creating a new global variable, I have to return the value of friend2. Now, we've tweaked the code so that friend2 is returned by returning the value. It is now in the main program. If we try and print it out now, you'll see that both Elliot and Rachel are printed. It might be helpful to think of scope like a building. A variable with local scope has permission to go to one floor. It can move around that floor and change anything it likes. If it doesn't like the wallpaper, it can change that, but only for that floor. However, a global variable has much more power. It can access any floor, changing as many things as it likes. It can make the walls of all the floors blue or pink or green. So why don't we just make all of our variables global? Well, for one, it saves something important called RAM, or Random Access Memory, which is a form of computer memory. While the computer has to remember the value of a global variable for the whole duration of a program, it only has to remember the value of a local variable while the function is being executed. Once the function has been executed, the local variable is wiped, and this frees up memory space. A nice rule of thumb is, if it's not needed in the main program, keep it local. So, that's scope. Luckily for us, the Make code editor is quite forgiving. If you try and print a local variable in the main program, the microbit will simply not print anything. But in other languages like Python, this can cause an error, which causes your whole program to stop. Notice how in the error message it says name friend2 is not defined. This means it doesn't know what this variable is. Now you can see how scope becomes really important as we write more complicated code. Alrighty, back to the code project. We're still in the tilt right block, and we're about to encounter something we haven't seen before, but that's very important. Conditional while loops. A conditional while loop is sort of like adding an if statement to a while loop. It says that while the condition is true, keep repeating that loop. Let's look at an example. Say we're hungry and just our luck, we've found an all-you-can-eat buffet. Here, our condition is that we are hungry. While we are hungry, we will continue to eat. Once we are no longer hungry, the condition is no longer true, so we do not eat, and we move past the while loop. Phew, that's a lot of theory, but now you'll be well prepared for today's code project. Let's start by initializing our variables. We have a few to keep track of in this program, so it's important we label them appropriately. In this program, we'll show examples of good names and bad names, and why it's important to name things properly. We'll start off with a variable called mass, which tells us how heavy our glove is in kilograms. Perhaps a kilo is a bit optimistic, but it's a nice number to work with for our rough estimate for energy. We've also got 3 more variables: list, total underscore force, and seconds. Straight off the bat, can you guess which one of these has been badly named? Have a little think, and we will come back to this in a minute or two. In our program, the condition in the while loop is while the running time of the program is less than 5,000 milliseconds, i.e. 5 seconds. Within our loop, we pause, take a sample of the acceleration and add it to list, which stores the acceleration at certain points. We then increase seconds by 0.5 to show that 0.5 seconds have passed. Once 5 seconds have passed, the condition is no longer satisfied and we exit the while loop. We play a beep to indicate we're no longer recording the glove's acceleration. That's all we can do in the tilt right block for now. We have 2 functions coming up: average acceleration and the maths function. The average acceleration function pretty much does what its name suggests. It finds the average acceleration of your hand while you shake. That's another thing. It's good practice to name your variables and functions so you can roughly know what they do. For example, if I had a variable which stored my age, it's much better to call it age instead of seaside. The average acceleration function loops through each entry in list. Each entry in list is a recorded acceleration. So, by adding up all the values, we get the total acceleration. Then, by dividing the number of entries, we get the average acceleration, which we can return. OK, so now knowing that we should use descriptive names for our variables, functions and lists, let's go back to our question from earlier. The badly named variable was list. Can you think of a better name? After all, it could be a list of anything. Maybe recorded accelerations, or simply accelerations would have been better. It means that anyone else reading our code will know what our variables store. This helps to make our code more open source friendly and links in with open source definition point 3. Our open source must be modifiable. For people to be able to modify, they have to be able to understand it first. So naming this correctly is important. Remember, at the start, when we spoke about local and global variables, take a look at the average acceleration function. Can you see any variables which have been created within the function? That's right, the value variable. Let's switch to Python code quickly. You can do this by clicking the Python button at the top of the Make Code editor. This will turn all our block code into text-based Python code. Scroll down until you find the average acceleration function. It should look something like this. Do you see how we've written global total underscore acceleration? This is because total underscore acceleration is a global variable. that we're using within the function. Now, can you see in our for loop, we use the local variable called value. This means its scope is limited to just being available inside the function. If you had another variable outside the function, also called value, it would be a completely different variable, and the two would not interfere with each other. The maths function is going to deal with all sorts of fancy maths that goes into calculating the new energy generated from our shaking the glove. We'll go by it step by step. You don't need to know what each of the steps mean. Let the physicists worry about the maths. It takes an input, the average acceleration calculated in the average acceleration function, and the very first step is to square it. We will assign this to a variable, very handily called acceleration squared. Our next variable, told you there were a lot of variables, is called v squared. This is shorthand for velocity squared and is equal to acceleration squared multiplied by 25. 25? Where's that come from? Well, we shake our microbit for 5 seconds, so it's simply the time squared. Our final step is to finally calculate the energy. This is equal to the mass multiplied by v squared, multiplied by a half. We've now got our energy. Return it, and we'll have a go at generating some energy. Great, we can measure energy. That will come in handy. But this was a tough lesson. I need a treat. Let's go and get a 99 from the ice cream van. Michael is going to meet us there. Rachel and I are still not speaking, so she won't join us. But, she can still use the code we created because it's open source and we can't decide not to share with someone or let them use it for a purpose we want to because we don't like that purpose. In today's lesson, you have learned the importance of energy and the impact the energy in our data consumption has on the environment. Understand that open source can be used for any purpose without restriction. Learn about scope and what the differences between local and global variables are. Learn what a conditional while loop is. Learn the importance of properly naming variables. I wonder if I should invite Rachel along too.